Alright, we're looking at how else to use the vector equation of a line. Here we're going to try and find the equation of a line running through 2 points. So these are the 2 points that we're going to find the equation of the line running through. And we're in 3 dimensions because these coordinates both have 3 parts and 3 ordinals in them. So we need to find a point that's on the line and a direction that the line goes in. Well, we've already got points, we've got 2 of them, easy peasy. Now the direction is going to be the bit that requires calculating. So if we call this point A and this point B, the vector that takes us from A to B can easily be calculated. So for the x component, we go from 3 to 4, so that's 4 take away 3 is 1. For the y component, we go from -1 to 2, so 2 take away -1 is 3, that's a step of 3. And in the y component, we're going from 4 to -1, so -1 take away 4 is -5. So that was the x values, the y values, the z values. Okay, so the vector 1, 3, -5 is the vector that goes from A to B, and therefore it's in the direction of the vector from A to B, rather obviously. But it's the direction that we care about. So this is the direction vector for the line. Now the line must go through one of these points, doesn't matter which, and it's some steps of that vector. Done. Easy as that. And again, the reason that this is an excellent way to write about lines using vectors, it doesn't matter how many dimensions we're in. This is a 6-dimensional coordinate. Make sure I've got the right. This is a 6-dimensional coordinate. Well, we call that R1. R2 is one of these points, 2, 3, 4, -2, 1, 2, plus some other multiple, we've used lambda, so I'm going to use mu this time, of, well, that to that is down 1, that to that is down 7, that to that is down 3, that to that is up 5, that to that is up 4, and that to that is 0, times that vector. And that's it. You've got the equation straight away. It's very, very efficient to use vectors for equations of lines because they scale very nicely into any complicated space. Now for your A-levels and further maths A-levels, you won't be having 4, 5, 6-dimensional problems. You'll be just capped at 3 because there's a physical interpretation linked to them. But as you actually start to do maths for interesting reasons, you will see that many problems can be thought of as multi-dimensional space, and vectors are very helpful to work in them. So I hope that's given you some insight as to why vector equations of lines are beneficial.